Okay, good morning class. This is lecture number 5 of our IS 106 subject. Um, this time, this is the first part of chapter 3, using statistics to summarize our data sets. In chapter 2, we talked about graphs, charts, and tables to describe our data set. This time, we use statistics to summarize data sets. Goals of the chapter are the following. After completing this chapter, you should be able to 1. Complete and interpret the mean, median, and mode for a set of data. 2. Compute the range, variance, and standard deviation and know what these values mean. Number 3. Compute and explain the coefficient of variation. Number 4. Use empirical measures to describe the shape of data sets. And those are the goals for the chapter class. Napay additional, 5th, measures of center and location, where in the data set are the mean, median, and mode. And other measures of location, which are the weighted mean, percentiles, as well as quartiles. And the last, the measures of variation, which are the range, the interquartile range, variance and standard deviation, as well as coefficient of variation. Now, these are all the measures in summary, which we are going to discuss in more details in the following slides. To describe the data numerically, we need to locate the center of the data set, where they are located, the center and the location of the mean, median, mode, as well as the weighted mean. Center and location of mean, median, mode, and the weighted mean. For other measures of location, alternate methods of measures of location of the center of the data set, we could use percentile ranks as well as quartile ranks. And for the variation, we need to know about the range, the interquartile range, variance, standard deviation, and the coefficient of variation. Now, the measures of center and location, or the central tendency of a data set. Where are they located? There are 4 as summarized here. There are 4. This 4. Now we'll talk more about them one by one. The mean here, graphically, the mean is the average, the arithmetic average of a data set. That is the sum of all the I from 1 to up to n, and divide by n, the number of the number of the sample. That's the mean, the arithmetic mean. The arithmetic mean is given by x with a bar at the top, this one X with a bar at the top. And this is the I think this is the sample mean. This is the population mean. I hope by now you can already tell the difference between a population and a sample, diba? We talked about it during the previous lectures. Now the median is another measure to know the center of the data set. In this case, here visually, the median is located somewhere here, not necessarily at the center, not necessarily at the very center, because there are things to consider for each of these terms. For mode, it could be to the left because it has more on this side, and the weighted mean is another something like the arithmetic mean, only that there's a weight for each of the variable that you need to compute. Now let's talk more about each of these concepts. The mean. What is the mean? Mean is a numerical measure of the center of a set of quantitative measures computed by dividing the sum of the values by the number of values in the data. Meaning, you sum the values of the data, you add them together, and then you divide by how many numbers there are, how many numbers you added in the first place. This is actually, as mentioned, the arithmetic mean. The mean is the arithmetic average of data values. And there are two kinds. Once again, the sample mean and the population mean. The sample mean is the arithmetic average of the sample taken from the population, while the population mean is the mean, the arithmetic average of the entire population. That is, if you take a census for all the individuals involved, a census, not a sample. This is the mean or the arithmetic average is the most common measure of central tendency. Central tendency talks about where in the data set is the center, or asang yang tunga-tunga, yung sentro. The mean equals the sum of values divided by the number of values. And this is affected, this measure is kind of determining where the center of the data set is affected by extreme values, or values that are outliers, or that values that lay unlike the other values, which these are extremes. It could be from both sides of the spectrum. Like here, for instance, there are 5, n is 5 here, 1, 2, 3, 4, 5. If you were to add all these numbers, 1, 2, 3, 4, 5 here, like here 1 plus 2 plus 3 plus 4 plus 5, you will get 15, right? And you divide it by the number of n, which is 5. 1, 2, 3, 4, 5. 15 divided by 5 equals 3. So 3 is the center of the data set here, because we have um, 5 data. Our data set has 5 elements, 1, 2, 3, 4, 5. We added their values and divide by the number of n, which is 5, and we get 3. That means the third element is the center of the data set. 1, 2, 3 is third element. While here, this is to show you that this kind of, to determine where the center of the data set is affected by extreme values. Say here, we have again 5 elements in a data set, but one is an outlier. It's different from the other, extreme value. The others are 1, 2, 3, 4, and the fifth element is 10. If we are to add them, 1 plus 2 plus 3 plus 4 plus 10, we get 20, and divided by the number of elements, which is 5, we get 4. So you see here is the fourth element now, which is the center of the data set. 1, 2, 3, 4 here, because there's an outlier that tips the balance. So the arithmetic average, or the mean, is affected or sensitive to extreme values. It can be affected by extreme values. Now here, example 3-1, computing the population mean, the average of the population. United Airlines, from the United Airlines. To stay competitive, United Airlines, headquartered in Chicago, must update its airplane fleet. Suppose United selects its planes from a list of 17 possible planes, including such models as the Boeing 747-100, Airbus 300-B4, and the DC-9-10. At a recent meeting, the chief operating officer asked a member of his staff to determine the mean fuel consumption rate per hour of operation for the population of 17 planes, 17 kinds of planes. So, what is the mean, the average fuel consumption rate per hour, kada oras, unsa kadagan nga fuel, gasolina ang ma-consume. He's asking for the mean, the arithmetic mean of the 17 airplanes. So step 1, collect data for the quantitative variable of interest. The variable of interest here are the fuel consumption. The manufacturers for each of the 17 planes were asked to provide the hourly fuel consumption in gallons for a flight between Chicago and New York City. These data are recorded as follows. The 17 data from the 17 plane manufacturers are as follows. This one, for B747-10, 3,529, that's gallon per hour fuel consumption. For this plane, it's 2,215. For DC-10, that's 2,174. Up to DC-9, 9-10, 764 gallons per hour of consumption. Now, step 2, add the data values. The total is you add all those numbers. You add all these numbers. I-sum, i-add, and then divide the sum. Divide the sum by the number of values in the population using equation 3.1, which is this one. The population mean is equal to the sum of all members of the data set divided by the big N, which is, this is for population. So the population is 17, right? So 22,659 gallons per hour divided by 17. So the answer is 1,332.9, and that is gallons per hour. The mean number of gallons of fuel consumed per hour on these 17 planes is this 1,332.9. Now, another example, 3-2, computing a sample mean. The other one was a population mean. This one is sample mean. The management salaries. The Dominic and Associates is a management search firm that locates qualified management talent for companies looking to fill a position. Meaning, the management salaries Dominic. This Dominic and Associates, this is a firm, a company that interviews applicants for management, and this time Dominic and Associates is interviewing or looking for a qualified management talent, possible nga mahimong manager for companies nga client sa Dominic and Associates. They have selected a sample of 7 recent placements and recorded the starting salaries. The following steps are used to calculate the sample mean salary. The average of the salary for the entry salary for the position of management. This is management salary. Step 1, collect the sample data. Always we need to collect the sample data, which are this one, $144,000, $98,000, $204,000, $177,000, $155,000, $316,000, and $100,000. These are the entry-level salaries for managers, and I guess this is annual salary for 12 months of a manager from different companies. The lowest would be $98,000, and the highest here is $316,000 per annum, per year, for 12 months. Then step 2, add the values in the sample, which is we add all these numbers, 144,000 plus 98,000 plus 204,000 plus 177,000 plus 155,000 plus 316,000 plus 100,000, which is equal to $1,194,000. Now step 3, divide the sum. This is the sum. Divide the sum by the sample size. The sample size is pila ka buok? 1, 2, 3, 4, 5, 6, 7. 7 sila ka buok. So, divide this 1,194,000 by 7. This one. 1,194,000 divided by 7. And the answer is $170,571.43. Therefore, the mean starting salary for the sample of 7 managers placed by Dominic and Associates is $170,571.43. That's the arithmetic mean, the average of the salaries, the 7 sample salaries they have. Now, let's consider the impact of extreme values. Extreme values. Suppose the sample of management's starting salaries, katong previously, had been slightly different. If the salary recorded as $316,000 had actually been $1 million, how would the mean be affected? We can see the impact as follows. Follow the same, collect the sample, but here we change one of the entry. The previous entry here was $316,000. Here we change it to 1 million, which is an extreme value for this kind of salary. An extreme value. Then step 2, add the values. We do the same as we did before, only that we change the previous $316,000 to 1 million. And this really blow up the sum. This is now, the sum is $1,878,000. In the previous sample, it's only $1,194,000. This time, it is $1,878,000. Now let's divide this number by 7. The n is 7. Now the average is now $268,285.71. With only one value in the sample changed, the mean is now substantially higher than before. The mean, the average. Because the mean is affected by extreme values, it may be a misleading measure of the data center. In this case, the mean is larger than all but one of the starting salaries. Dako kay diferensya kung nay isa ka extreme nga value. So na-change ang center of the data set. Now that was about the mean or the average, the arithmetic mean. Now let's deal with the median. What is a median? The median is a center value, like the mean, a center value, that divides a data array into two halves. We use the mu with the tilde at above to denote the population median, and capital M with sub alpha, this is alpha, to denote the sample median. Okay, a median. This is how a median looks like. This was shown earlier, but this time it has more explanation. And this is not affected by extreme values. Say, katong kaganiha, we have a sample of 5, as a data set of 5 sample elements. Here also, although one is an extreme value, the median still remains the same. It is the third element of the data set. But and it's the same. Parehas, it's not affected by extreme values. In an ordered array, I hope you understand. You can relate what an array is. I understand you have been programming in C using array as your data structure. The median is the middle number. If n, this sample or big N, which is the population, is odd, kanang dili pares, the median is the middle number. In this case, the sample is 5, which is odd. The median is the third sample, third element. The same here, 5 man ang N. It's the third element, which is the median. If it is even, pares, the median is the average of the two middle numbers. Okay. Like kung even, kung pareha sila, katong duha ka number na nastunga-tunga, i-add to nimo nya i-divide by 2. Here's a sample here. Computing the median. Again, this is management salaries. The same data set that we worked in earlier example. Step 1, always collect the sample data. Management salaries are the data set are the following, the same. Katong original nga data set na 316,000 ang second to the last nga element. Step 2, sort the data from smallest to largest, forming a data array. Now, step 2, the result is a sorted data from small to highest, from lowest to highest. Then step 3, calculate the median index. Median index, ang tunga-tunga niya, we get I equals 1/2 divided by 7 because n is 7. 7 man is lakabuok 1, 2, 3, 4, 5, 6, 7. 1/2 times 7 equals 3.5. Rounding up, the median is the fourth value from either end of the data array. So bisag asa ka 3.5 then find the median. The fourth value of the sample is this 1 2 3 4 1 2 3 4 it katunga siya sa data set. The median salary is $155,000. The notation for the sample median is this one, sample median. Capital M sub alpha, that's alpha. Or looks more like a lowercase na d. Now, how about the mode? We finished with mean, we finished with median. Now, the mode. The mode is the value in a data set that occurs most frequently. Itong pinakadaghan nga data sa data set. Pinakadaghan nga parehas. It is not affected by extreme values like the mean. Also like the median is not affected by extreme values. And it is used for either numerical or categorical data. Remember categorical data like gender, male, female, marital status, single, married, divorce, separated, and the like. Those are categorical data. Sometimes there can be no mode at all in the data set. Like here, there's no mode because equal ang distribution. There are seven elements in the data set from 0 to 6 and equal ang ilahang distribution tag 1 lang. So wala siya mode. Whereas here in this data set from 1 to 14 ang iyang range, ang pinakadaghan o occurrence or frequency is number 5. There are 3. Ang 9 o 12 has only 2. So ang most frequent element is 5. So the mode is 5. So that's is said to be the center of the data set, this element number 5. Now, another example, determining the mode from Smoky Mountain Pizza. The owners of Smoky Mountain Pizza are planning to expand their restaurant to include an open-air patio. Before finalizing the design, the managers want to know what the most frequently occurring group size is so they can organize the seating arrangements to best meet demand. They wish to know the mode, which can be calculated using the following steps. Okay, step 1, collect the sample data. A sample of 20 groups was selected at random. Remember random? These data are 2, 4, 1, 2, 3, 2, 4, 2, 3, 6, 8, 4, 2, 1, 7, 4, 2, 4, 4, 3. 20 groups of customers of that size. Now, step 2, organize the data into a frequency distribution. Frequency distribution. Okay, for 1, the occurrence of 1, for the group of 20, there were 2. For a group of 2, there were 6 groups. For a group of 3, there were 3 groups. For a group of 4, for customers, there were 6. For a group of 5, there were none, 0. For a group of 6, there was 1. For a group of 7, there was also 1. And for a group of 8, there was also 1. For a total of 20. So, what is now the frequency? The mode. Step 3, determine the values that occurs most frequently. In this case, there are 2 modes because the values 2 and 4, 2 and 4, each occurred 6 times. Thus, the modes are 2 and 4. So, possibly, class nga, more than 1 ang center of the data set. In this case, it's 2 and 4. Now, that was mode, mean, median, mode. Now, this time it's another measure to know where the center of a sample is the weighted mean. It's the same. It's a mean. It's still the mean, the average, arithmetic average. Only this time it is weighted by another factor. It's multiplied by another factor. And weighted mean is used when values are grouped by frequency or have been grouped according to their relative importance. Example, a sample of 26 repair projects. Here, days to complete and frequency. 26 sample projects. For 5 days, there were 4 projects that was completed in 5 days. For 6 days, there were 12. For 7 days, there were 8 projects. And for 8 days to complete, there were 2 projects, for a total of 26. Because this one, 12 plus 8 is 20. 12 plus 8 is 20, plus 4, 24, plus 2 is 26. Now, the weighted mean days to complete, the weighted, is calculated like this. The sum, we take the sum of weight sub I multiplied by x sub I and divide that sum by the sum of the W sub I, which by substitution in this sample we multiply 4 times 5, 4 times 5, plus 12 times 6, plus 8 times 7, plus 2 times 8. You take the sum of that divided by the number of kinailan siya, kinira, kana 4 plus 12, 4 plus 12, 8 plus 8, and plus 2. Then reduce to lowest term. Kana sila equals 164, and kana sila ang sum is 26. The final answer is 6.31 days. That's the weighted average, or the weighted mean, the weighted average. That's the center of the data set, this data set. Now, these are the, as usual, we have formula for the population and formula for the sample. Population is represented by the Greek alphabet mu. This is mu. Mu sub w equals the total of w sub I multiplied by x sub I divided by the total of the sum of w sub I, or all the elements in the array, or all of the elements in the sample or the population. Now the formula for weighted mean for sample is very similar, actually, very similar. The only difference is the symbol here. For population, the symbol is the Greek letter mu. For sample, it's the X bar. X nga na ay bar sa ibabaw. Where the W sub I is the weight of the ith data value. The I here, class, is if you use an array, I would be the counter of the array. Here, the X sub I is the ith data value. Sample. Example. Calculating a weighted population mean. Recently, the law firm of Mayers and Associates was involved in litigating a discrimination suit concerning ski instructors at a ski resort in Colorado. One ski instructor from Germany had sued the operator of the ski resort, iyang kiha sa korte, claiming he had not received equitable pay compared with the other ski instructors from Norway and the United States. In preparing a defense, the mayor's attorneys planned to compute the mean annual income for all 7 Norwegian ski instructors at the resort. However, because these instructors worked different numbers of days during the ski season, a weighted mean needed to be computed, and this was done using the following steps. Step 1, as always, collect the desired data and determine the weight to be assigned to each data value. In this case, the variable of interest was the income of the ski instructors. The population consisted of 7 Norwegian instructors. The weights were the number of the days that the instructors worked. The following data and weights are determined. For income, X sub I, $7,600. 3,900, 5,300, 4,000, 7,200, 2,300, and 5,100. For the days worked, this guy here, this instructor, worked 50 days. This instructor worked 30 days. This instructor worked 40. This one worked 25. This one worked 60. This one worked only 15. And this instructor worked for 50 days. And that's their salary from the resort for an entire year, with a varying number of days that they work. Step 2, multiply each weight by the data value and sum these numbers. Like this. 50 kini sila i-multiply ni i-multiply po ni multiply na sila, then i-add ang ilang product. Ang product ini i-add nimo diha, i-add po nimo na unang step 2. The total is $1,530,500. Now step 3, sum the weights for all values. These are the weights, are the days na when the number of days that each instructor worked, which is a total of 270. Now compute the weighted mean. Divide the weighted sum by the sum of the weights. Because we are working with the population, the result will be the population mean, the population weighted mean, which is $1,530,500. $1,530,500 divided by 270, this one. So the result is $5,668.52. Thus, taking into account the number of days worked, the Norwegian ski instructors had a mean income of $5,668 and 52 cents. Let's skip that. Now there's a question here. Which measure of location is the best? Asa man daw ang pinakamaayo nga measure to determine the center of the data set? Is it the mean, the median, or the mode? It says here the mean is generally used unless extreme values exist. Kung na ay mga unexpected mga outliers kanang dili obviously nga mga dili kauban sa grupo, lahi kayo sila. Generally it is the mean. Then median is often used also, since the median is not sensitive to extreme values. Only rarely is the mode is used. And the weighted mean is also when like the salary, when the days worked are not equal. Now let's talk about the shape of the distribution of the data elements in a data set. It is often plotted. When plotted the data set, um, we can describe if it is something like normal or not normal. It describes the shape of the data set, describes how data is distributed, whether it is symmetric or skewed. Skewed is kanang um, dili kaayo siya kini mo symmetric kanang pare sila og shape left o right, pare sila og shape, equal ang ilang shape, murag mirror image. Nindot siya, mas nindot siya tanawon, equal. And skewed is like this. In one side, here there is a symmetric, ang mean, median, and mode are equal. Pareha sila. Ang mean, median, mode parehas. Whereas sa left skewed, the median is higher than the mean, but it is also lower than the mode. So, ang median na dire, ang mode na dire, ang mean na diha. Wala, dili sila synchronized. The same with the right skewed distribution. Dili po sila synchronized. The median is higher than the mode, but the median is lower than the mean. So that's why it is right skewed. Dili sila evenly distributed. Now let's talk about other location measures. What are these other location measures or other measures used to locate certain parts of the data set? Not necessarily the center, but certain parts of the data sets. These are the percentiles and the quartiles. The percentiles refers to the pth percentile in a data array. If your data is sorted and stored in an array, a percentile is the pth percentile in a data array. P% are less than or equal to this value, where where 100, the P% is taken from 100. 100 here is constant from 100%. You minus it with the value of P and turn it into a percent. These are greater than or equal to this particular value, where P is greater or equal to 0, but maybe less than or equal to 100. Whereas in quarters from the word quarter, 1/4. First quartile is the 25th percentile. Second quartile is the 50th percentile, which is sometimes the same as the median, katunga, or it could be the same as the mean. The third quartile is the 75th percentile. Now, what are percentiles? You might be wondering, what are percentiles? In some applications, we might wish to describe the location of the data in terms other than the center of the data. So, for example, prior to enrolling at your university, you took, let's say this is in the US, the SAT or ACT test, and received a percentile score in math and verbal skills. If you received word that your standardized exam score was at the 90th percentile, it means that you scored as high as or higher than 90% of the other students who took the exam. The score of the 50th percentile would indicate that you were at the median, nakastunga-tunga, where at least 50% scored at or below you, and at least 50% scored at or parehas or above your score. Is the formula class for finding the kth percentile. If you were to do a little research, you would find several formulas for calculating the kth percentile. Here is one of them. It is one of the formula. This is not the only formula. K is equals the kth percentile. It may or may not be part of the data at all. I is the index or ranking or position of a data value in the total number of data points or observations. First, order the data from smallest to highest, or sort it, ascending, small to big. Then calculate I using the key over 100 times n, multiply it by n plus 1. If I is an integer, then the kth percentile is the data value in the ith position in the ordered set of data. If I is not an integer, then round I up and round I down to the nearest integers. Kaduha, duha imong buhaton kung dili integer ang number, kung real number siya o floating. Alanganin ba? Alanganin siya. You round up the I and also round it down to the nearest integers. Average the two data value positions in the ordered data set. Now this is easier to understand in an example. We have an example that follow. Sample 2.18. Listed are 29 ages for Academy Award-winning Best Actors in order from the smallest to largest. So the youngest is 18 and the oldest is 77. Remember the ages of the authors in our first laboratory exercises. We did something like this. Di ba we determined the youngest author and as well as the oldest author, and we take the range, di ba? Here is similar, only that there are 29 ages for Academy Award winning Best Actors, sorted from smallest to largest. One question is find the 70th percentile. 70th percentile. For 70th percentile class, the K is 70 because you are looking for the 70th percentile. The K is 70, I is the index, N is 29, N is 29. So I is the unknown here. So you can get the value of I from this formula, where K divided by 100 multiplied by N plus 1. By substitution, K is 70. K is 70. Now, you divide that, 70 divided by 100. That must be 0.7. Multiply that by 29 plus 1, which is 30. The answer is 21. Now, 21 is an integer, a whole number, and the data value in the 21st position in the ordered data set is 64. So the 70th percentile is 64 years old. In this data set, the 70th percentile is 64 years old. Let's count the 21st position down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 is 64 years old. Okay? It's the 70th percentile. That means 30% could be higher and could be older. 30% could be older than him or her, and at the same time 70% of the other Academy Award winners are younger than this guy. Okay. Another question. Still the same data set, ordered data set 29. Letter B, question letter B. Find the 83rd percentile. 83rd percentile, where I is the index, N is still 29, where I can be found by K over 100 divided by N plus 1. The percentile we're looking for is 83, which is K divided by 100. That would be 0.83. Multiply that by 29 plus 1, which is 30. The answer is 24.9, which is not an integer. 24.9 is not an integer. It's not a whole number. So, round it down to 24. Round it down to 24. And round it up to 25. 24 and 25. The age in the 24th position is 71. Kinesia 71. Ang ika-24th position. And the age in the 25th is 72. So, average 71 and 72. The 83rd percentile is 71.5 years. Nasa tunga sa ila. Ang 83rd percentile. Okay. Now we will just remember this class. You will do this in the lab, during your lab exercise. This will be one of the items in your lab exercise number 2. Still the same data as this one, but now we calculate the 20th percentile and the 50th percentile. Now, let's stop here, class. Um, just remember, you will do this exercise in your next. This will be one of your exercises in your next lab exercise, which is exercise number 2. And for lecture number 6, we will start with quartiles. So for now, we have discussed mean, median, mode, and weighted average, and percentiles. So, any questions, class, you can note down, and you can ask me during the face-to-face lab session. That's all for now.